Welcome back. We're going to talk about mass again. There's an interesting concept we can learn here. You might ask, why use a double integral when you can do a single integral? Well, the answer is sometimes you need a double integral, sometimes you don't. We want to find the mass of a rectangular plate bounded by this Cartesian product. It's just this square in the first quadrant. With density rho equals 3x squared kilogram per square meter. Now this density varies with one variable. If it varies with one variable, we can use a single integral. You could use a single integral or a double integral, whatever your choice is. Over here I have a little picture, 0 to 3, 0 to 3. You can actually take a rectangular element. The width is going to be dx, the height's going to be 3, so dA is 3dx, that's the area of this rectangular element. And the mass of this rectangular element is density times area, 3x squared times 3dx. Now we can actually integrate a single integral. It's going to be an x integral. You can write this as 9x squared dx. And of course x has to go from 0 to 3. And so we do 0 to 3, and we get 9x cubed over 3 from 0 to 3, and 3x cubed from 0 to 3, and we end up getting 27 times 3, 81 kilograms is going to be the mass. We can do it as a single integral along the axes where this varies with. If this was 3y squared, we'd have to use horizontal strips and integrate along the y-axis. If we want to use a double integral, so be it. Mass would be integral 0 to 3, integral 0 to 3, 3x squared dy dx. You could do it dy dx or dx dy, it wouldn't really matter. And we can integrate 3x squared dy gives us 0 to 3, 3x squared y from 0 to 3 dx. Okay, plug in 3, plug in 0. We end up getting integral 0 to 3, 9x squared dx. Okay. Where have we seen that before? Well, guess what? That integral is the same as this integral right here. Okay, and so we don't need to reinvent the wheel. The answer is 81 kilograms. So, of course, if this was 3x squared y squared, if the density varied on both axes, well, guess what? We'd be forced, we would have to use a double integral, couldn't use a single integral. So we have that as a tool whenever we want to add up something that varies with in both directions. So yeah, that's all for this example. Your problem set has one problem with the density varying with x, another problem with the density varying with y. You just need to do a horizontal strip, and this is going to be dy instead of dx. So that's all.